So, shall we start, sir?
Vichi, we can start if you are ready.
Yeah, yes, sir, we are ready. So, good evening to all respected dignitaries, our esteemed resource persons, fellow faculty members, and our dear participants joining us from different parts of India. On behalf of Department of Mathematics, Wilson College Autonomous Mumbai, it gives me
Vichi,
immense.
we can start if you are ready.
Yeah, on behalf of Department of Mathematics, Wilson College, Mumbai, it gives me immense pleasure to welcome you all to the inauguration ceremony of IIT JAM Mathematics online lecture series 25-26, organized under the aegis of DBT Star Strengthening Scheme. With its remarkable 189-year legacy, Wilson College continues to blend tradition with innovation, and this lecture series is a reflection of our commitment to academic excellence and outreach. This initiative began last year on a smaller scale, a 20-hour lecture series aimed at preparing students for the IIT JAM mathematics examination. The overwhelming appreciation and positive feedback from participants inspired us to take it to the next level. This year, we are proud to present a 40-hour series with an expanded set of topics and eminent resource persons from across India. And the response has been nothing short of phenomenal. 800 registrations nationwide, truly making this a pan India learning platform. Before we hear from our esteemed guest, let us revisit some wonderful moments from last year's lecture series, which laid the foundation for today's grander initiative. I hope I'm audible.
Yeah, Birji, now you are audible. There was some disturbance.
There was some internet issues. So I'll continue. We are honored to host our beloved principal, Ramachandran Bhatia, our guiding light and chief guest for today's ceremony. With great privilege, I invite our principal to deliver the inaugural address and formally inaugurate the IIT JAM Mathematics online lecture series. Over to you, sir.
Okay, Birji, can you hear me clearly?
Yes, sir. Yes.
Okay, good evening, everyone, especially the participants from all over the country. Let me first of all say thanks to you because of you, this workshop is going to be, this series is going to be successful. And as you have heard from our HOD from the maths department, she has already shared that how overwhelming, response we have received across the India. So thus it is my pleasure to be here today for this special, IIT JAM Mathematics lecture series, which is organized by our esteemed Department of Mathematics. And friends, I just want to talk about the mathematics. Generally, we are so afraid that as a subject, this is a subject of numbers and formulas. But I feel, because I had also studied maths, it is a language of logic, precision, and creativity. And this lecture series will give you a wonderful opportunity and platform for all the students who have joined the series from across the country to strengthen you in your conceptual understanding, sharpen your problem solving skills, and build the confidence needed to excel in competing exams, especially the IIT JAM. This series will also reflects the dedication of our faculty members. As you can see, though it is around 6 o'clock, but they are still present in the college, facing the challenges with the internet, but they are not giving up. They are always ready for their students and for the students across the India. And as mentioned, madam has mentioned that this is one of the biggest series is because of the number of participants, those who have shown interest, under Pan India. And I'm so thankful to all of you, Bridgie, and your team. And they are so committed to nurturing, academic excellence, not only in Wilson College, but across the city of Mumbai and also now across the India. I encourage all of you, dear students, participants, to take full advantage of these sessions, which are going to be dealt from now onwards. Do not hesitate to ask questions. Okay, engage actively in every session, in every lectures, and apply what you learn beyond the classroom. Then only it is going to be a successful, platform for all of you and for all of us. Remember once again that mathematics rewards curiosity, perseverance, and clarity of thoughts. And thus, I want to extend my heartfelt thank to the organizer, especially to my esteemed Department of Mathematics colleagues, Dr. Birji, Dr. Tina, Prathamesh is there, and the other faculty members. Thank you for your initiative to organize this under the DVT grant scheme. I am also thankful to our speaker for the day. So, sir, thank you once again to you, sir. And Virji, your departments had put really a very hard work, together to make this initiative successful. And may this lecture series inspire all the participants to aim higher, think deeper, and achieve their goals. This will help them. Thank you once again, and best wishes to all of you. Thank you, Virji, once again to invite me.
Thank you so much, sir, for such motivational talk. Uh, Now, dear students, over the next several months, our sessions will cover algebra, analysis, calculus, linear algebra, ordinary differential equation, abstract algebra, and more, with a problem solving approach and a focus on effective strategies for competitive exams. Each session will have live question and answer, assignments with expert feedback, and time bound practice sessions, ensuring a comprehensive preparation experience. On behalf of Department of Mathematics, I extend heartfelt thanks to the DBT Star Strengthening Scheme for their support. I also wish to express our sincere gratitude to our leadership and senior academic support, those to whom we turn whenever we have challenges or simply need motivation to move forward. Your encouragement gives us the confidence to take on bigger initiatives here. The college management for putting a Zoom platform. We are grateful to our resource persons for their dedication, my co-conveners for their continuous efforts, and our participants for making this a truly national academic event. Wishing everyone a productive and inspiring journey ahead. Let us now proceed to our first session. Thank you very much, Jamson sir. It means a lot that you have been a present in this session and inaugurated. Thank you very much.
No problem, Bridgie. All the very best again, participants, and to all my colleagues, and especially thank you, sir, once again, our esteemed speaker of the day.
So I now invite my colleague, Miss Madhvi Singh, to formally introduce our today's resource person.
Good evening, everyone. I would like to extend a warm welcome to Dr. Dipak sir, who is an associate professor from CHM College, Ulhasnagar. He has graciously agreed to take another session for students preparing for IIT JAM Mathematics. We appreciate his continuous support and expertise. Dr. Deepak sir, previous lecture have greatly benefited participant during last time workshop, and we are grateful for his willingness to share his knowledge again. Let us give him a warm welcome and make the most of this opportunity, sir. Over to you, sir.
Thank you, madam. Am I audible to all of you?
Welcome, sir. Yeah, yes, sir.
Okay, so I hope I am audible. I would like to thank Principal Dr. Jamson Masia sir and organizers of the IIT JAM lecture series, Wilson College, Mathematics Department of Wilson College, for giving me opportunity to address such a huge number of participants who are participating in this workshop across the country.
Sir, we have made you the sorry, sir. Sir, we have made you the co-host.
Okay, thank you, madam. So let
Yes.
me share. Is my screen visible to all of you? Oh,
Yes, sir.
Yes, sir.
okay. So I suppose all of you are going to appear for this JAM IIT entrance exam for MSc Mathematics course in the near future. So there are several topics listed in the syllabus of the exam. I'm going to consider two topics from that: sequences and series. So I hope all of you have studied basics of sequences as well as series in your possibly in FY or maybe in second year. So let us revise. Sequences is nothing but a function from set of natural numbers to set of real numbers. So it is just a quick recap of the topic. Soon we will go to solving problems from the past year question papers of IIT JAM exam. So sequences is simply a function from set of natural numbers to set of real numbers. These are also called as real sequences. Basically, we are considering sequences in real numbers. Once we define sequence, what we define is nothing but limit of a sequence. A sequence xn converges to L, a real number. What do we mean by that? So for every epsilon, there is a natural number n naught, such that mod of xn minus L less than epsilon for all n greater than or equal to n naught. Means as we proceed along the sequence, the terms of the sequence are going close and close to some fixed real number. Then we say that sequence converges to that fixed real number, and that real number is called as limit of a sequence. I hope this definition is known to all of you. Once we study the definition of limit of a sequence, the immediate question that one can ask, is it possible that sequence may converge more than one limit? So answer is no, which is guaranteed by the theorem uniqueness of limit of a sequence. Means whenever a sequence converges, it converges to unique limit. Then it's a task to calculate limit of a given sequence, for which we have learned several theorems in our undergraduate course. Like first of all, what we have learned is algebra of sequences. Means if two sequences are convergent, then their addition is also convergent, and their addition is converges to addition of their limits. If two sequence converges, then their subtraction is also convergent, and it converges to subtraction of their limits. Scalar times a sequence is also convergent, and multiplication of two sequences is also convergent. So all this comes under the algebra of sequences. Then what comes in the picture is the definition of bounded sequences. What do we mean by a sequence is bounded? There exists a positive real number m greater than 0 such that mod of xn is less than or equal to m for all n in n. So there are several questions in IIT JAM past year papers you must have observed which ask about a sequence is given and whether it is bounded, whether it is convergent, if it is convergent, where does it converges, and so on. So what do we mean by bounded sequence? If you have a positive number m such that every term of that sequence is bounded by that positive number m, then we say such a sequence is bounded. Then we have some theorems which we have studied that every convergence, there's a relationship between convergent sequence and bounded sequence. That every convergent sequence implies it is also bounded. But we all know that converse is not true. The standard example is minus 1 raised to n. This is bounded but not convergent. Then we have learned several theorems like if xn converges to limit p, then you take absolute value of each term of your sequence. Where does it converges? It converges to absolute value of a limit. Again, converse of this statement is not true in general. Converse holds only if p is equal to 0. xn converges to 0 if and only if mod xn converges to 0. So I am recollecting the results which we may require while solving the problems. Suppose you have two sequences xn and yn. Xn is bounded and yn goes to 0. Then what can we say about the product? Will go to 0. If you have two sequences xn satisfying this condition, xn less than or equal to yn for every n, then limit of xn is also less than or equal to limit of yn. Then we must have learned sandwich theorem, or sometimes also called as squeeze theorem. What does it says? You have three sequences xn, yn and zn. All three sequences satisfy this relation. Term wise we have xn less than or equal to yn less than or equal to zn, and xn converges to L, zn also converges to L. That means outer extreme end sequences are converging to same real number. Then the middle sequence yn is also convergent and it converges to L. Most of the time, this theorem gives us help to check whether a given sequence is convergent or divergent. What do I mean by divergent? If a sequence is not convergent, we will call them as divergent sequences. And we have studied some special kind of sequences. Like for example, if absolute value of a is less than 1, then the sequence of the type a raised to n, where does it goes? Anybody knows?
0.
0. Yes, very good. If a is greater than 0, a real number, then a raised to 1 by n, where does it goes?
1.
Yes. Then one most important sequence is of this type. Xn is equal to nth root of n for all n in n. Where does the sequence goes?
1.
Again, it goes to 1. Yeah, correct. So after studying this special kind of sequences, then we come across something called as increasing sequence and decreasing sequence. Xn is less than or equal to xn plus 1. That means next term is higher than the previous term. Then such a sequence is called as increasing sequence. If next term is smaller than previous term, then such a sequence is called as decreasing sequence. A sequence is either increasing or decreasing is called as monotonic sequence. Is that okay? And the result that you have learned, it says that monotonic plus bounded sequence is always convergent sequence. Meanwhile, we also came across something called as Cauchy sequences. A sequence xn is Cauchy if for every epsilon there is a natural number n naught, such that distance between two terms in the sequence is less than epsilon after that n naught. Such a sequence is called as Cauchy sequence. So this helps us if it is not possible to talk about limit of a sequence, but still we want to say the sequence somewhat behaves like a convergent sequence. Then we can talk about Cauchy sequences. Then there's a relation between convergent sequence and Cauchy sequence, which goes like this. I hope it is known to all of you. Every convergent sequence is Cauchy sequence. What about the converse of the above statement? So converse is not true in general, but what do we know is that Cauchy sequence is convergent in R. So the space in which you are talking about converse of the statement, that plays an important role when we look the converse of the statement.
Sir,
Cauchy sequence, yeah.
sir, can you please give an example where a sequence is Cauchy but not convergent?
Okay. Yeah. Very simple example. Xn is equal to 1 by n for all n in n. But I am observing the sequence in open interval 0, 1. So
Okay,
we
got it,
all,
sir.
yeah. So that's why I said the space wherein you are considering that sequence, that plays an important role for the converse of the above statement. Is that okay? I hope it is clear.
Yes, sir.
Okay.
Now, can you explain this again?
Cauchy sequence, I hope all of you know the definition.
Yes, sir. This example.
Yeah. This example, what does gives a counter example for the converse of the statement. The statement goes like this: every convergent sequence is Cauchy. That's a standard proof we must have proved in class. The converse of this statement is Cauchy sequence is convergent. Every Cauchy sequence is convergent. That's not true. It depends on underlying space in which you are considering the sequence. So here is an example. The sequence xn is equal to 1 by n, and the space in which you are considering is open interval 0, 1. So we all know that the sequence xn goes to 0. But 0 doesn't belongs to open interval 0, 1. I hope it is clear. Yeah. So this implies xn is Cauchy, but not convergent. Yeah. Can I say like this?
Sir,
Yes.
can you explain what is Cauchy sequence, sir?
Cauchy sequence is this.
Sir,
Yes.
how to say 1 by n is a Cauchy sequence?
Yeah. So in that case, you need to estimate this xn minus xn, this modulus. What it will be? It's 1 by n minus 1 by n. Yeah. Is it okay? Because xn is 1 by n. So xm is 1 by n.
Yes, sir.
So this is so this is less than equal to 1 by n plus 1 by m. Can I say like this?
Yes, sir.
Yeah. So what is the
What do you
definition
mean
of
by
Cauchy?
Cauchy sequence?
Yeah. Here it's a definition of Cauchy sequence. A sequence xn is said to be Cauchy if for every epsilon greater than 0, there exists n naught, a natural number n, such that you have this condition valid: mod of xn minus xm less than epsilon for all n and m greater than equal to n naught. That means this is your sequence x1, x2, and so on. So after a stage, distance between any two terms of the sequence is less than epsilon. Whenever this condition holds, we say that sequence is a Cauchy sequence. I hope the definition is clear to all of you.
Yes, sir.
Yeah. Okay. Now you want to say that the sequence is Cauchy sequence. That means by definition, for every epsilon, you need to produce a natural number n naught such that this modulus is bounded by epsilon. So we try to estimate this modulus. So what is this modulus? Mod of xn minus xn. So what is that? Mod of xn minus xn? 1 by n minus 1 by m. So it's a simple use of triangle inequality. Less than equal to 1 by n minus 1 by m. Now, you can choose, you want this to be less than epsilon. This we want to be less than epsilon. So we want 1 by n plus 1 by m less than epsilon. So if we choose, or if we make one by n to be less than epsilon by 2 and 1 by m to be less than epsilon by 2, then their addition will be less than epsilon. That means n is greater than 2 by epsilon. N is greater than 2 by epsilon. Take the reciprocal on both sides. So choose n naught, a natural number, such that n naught is greater than 2 by epsilon. Is it possible to choose such a natural number?
Yes, it is.
Yes, sir, it
Yeah,
is.
good. Yes. Then what we have for any n and m, which is greater than or equal to n naught, what we will have, n is also greater than 2 by epsilon and m is also greater than 2 by epsilon. So the reciprocal are less than epsilon by 2. Substitute here, you will have, substitute in star, what we will have, mod of, so from star, mod of xn minus xm is less than epsilon. So that proves the sequence is Cauchy. The sequence is Cauchy. But anyway, you must have proved a result which says every convergent sequence is Cauchy. So this sequence converges in R. So in R it is Cauchy. So everywhere it is Cauchy. So the sequence is Cauchy but not convergent in open interval 0, 1. Why? Because the limit does not belong to domain. So converse of the statement in general it is not true. But if you consider converse of the statement in a set of real numbers, then it is true. Then it is true. I hope this much recap is fine for all of you.
Yes, sir.
Yeah.
Sir.
So now we will go on solving the problems from past papers. Look at this problem. So there is some sequence given and we want to compute limit of the sequence. So when I say xn converges to L, it can also be written like this: limit n tends to infinity of xn is equal to L. Yeah. So how will you solve this? I hope it's an easy problem. Look at the numerator. It is 2 raised to n plus 1. So that you can write it as 2 into 2 raised to n plus 3 raised to n plus 1. That you can write it as 3 raised to 3 into 3 raised to n. Upon the denominator is 2 raised to n plus 3 raised to n. Then what will you do?
Sir, divide throughout by 2 raised to n, 3 raised to n.
Yeah, by any one number you can divide throughout. So
So
that you
divide
have
by
to
3 raised to the power n.
Yeah, good. So limit n tends to infinity. You divide numerator and denominator both by 3 raised to n. So what you will get? I hope you will get something like this. 2 by 3 raised to n plus 3 into 1 upon denominator is 2 by 3 raised to n plus 1. Yeah, is it the same thing that you will get? And then you can use algebra of sequences. You can split the limit. So where does this sequence goes? What is the limit of this sequence?
0.
0? Yeah. So here we have used a special sequence. This, I hope it is clear to all of you. If absolute value of a is less than 1, then a raised to n will go to 0. So what is a here? A here is 2 by 3, which is less than 1. So this limit is 0. So what is the final answer then? 2 into 0 plus 3 upon 0 plus 1. That's 3. Yeah, good. So option A. All of you, please go through this carefully.
Sir,
Yes.
sir, if we divide throughout by 2 raised to n, then the first part in the numerator, that is 2 by 3 raised to n, that will not get cancelled. The 3 raised to n part will tend to 0. So the answer will then come as 2.
Okay. Let us see what happens if you divide by 2 raised to n throughout. So you will have 2 into 1 plus 3 into 3 by 2 raised to n. This is what you will get in the numerator.
Yes, sir.
Yeah, good. And denominator you will have something like this.
Yes, sir.
In this case, we end up getting this limit. Do you observe? It's 3 by 2 raised to n. Yes, what is the limit of this?
Oh, so this goes to 1, sir. Okay.
Yeah. So this limit does not exist. I hope it is followed to you. Limit does not exist because here the absolute value of a is not less than 1. It's greater than 1. The result says if mod a is less than 1, then a raised to n goes to 0.
Got it, sir.
Good. So that's why we have divided by 3, so that the sequence will end up getting a is less than 1. Okay, good. So try this second problem. I hope it is visible to all of you.
Sir,
Yes.
A value is 1.5. How to say this is less than 1?
Which? In the above
3,
example?
yes, sir. 3 by 2 is 1.5.
Yeah.
But 1.5 is not less than or equal to 1, sir. So
Yeah. So it is greater than 1. No?
Okay.
So we cannot apply this result.
Okay, sir.
We cannot apply this result because this result valid only if mod a is less than 1.
Mod of A is equal to less than 1. Okay.
Yeah. And here you can observe 1.5 raised to n. The terms of the sequence. The first term is 1.5, second term is 2.25, and so on. So you can observe shoot up to infinity.
Okay,
So,
sir.
Good. This is also a question taken from past year paper. So let's see how we can solve this. So finally, we want limit of xn. Two raised to 2n 1 minus cos of 1 by 2 raised to n. So do you remember any identity related to such kind of expression?
So can you use the expansion of cos x, so cos 1 by 2?
Cos 1 by 2 raised to n. What is the expansion which you are talking about?
It will be 1 minus 1 by 2 raised to the power 2n divided by 2 factorial plus it goes on.
Means you mean in terms of power series or what?
Yes, sir. Also,
Can you repeat again?
it will go like, sir, 1 minus cos to the cos 1 by 2 raised to the power n divided by 2 factorial plus 1 by 2 raised to the power 4n divided by 4 factorial.
Okay, so you are using this cos x is equal to 1 minus x square by 2
Yeah.
factorial
Yes,
plus
sir.
x is to 4 by 4 factorial.
Yes, sir, by using
minus
Taylor's
and
law.
yeah, Taylor expansion. Good. Yeah. You can use that, but here there's no need of using that. Do you remember any identity related to this 1 minus cos theta?
2 sine square x by 2.
Yeah, correct. 2 sine square theta by 2. So can you use this here? So what you will get after using this? 2 sine square theta by 2. So 1 by 2 raised to n divided by 2. Yeah.
Yes, sir.
So then how will you manipulate this? 2 sine square. This 1 by 2 raised to n plus 1. Yeah. This 2 raised to n will go in the denominator. So that becomes 2 raised to n plus 1. And this 2 raised to n, this we will take in the denominator. 1 upon 2 raised to 2 raised to n whole square. Can I write it like this? 2 raised to 2n can be written something like this. Yeah.
Yes, sir.
Yeah. Then how will you manipulate the angle? Here the angle is 2 raised to n plus 1. And here we have just 2 raised to n. So you need to multiply 2 inside. 2 into sine square 1 by 2 raised to n plus 1 divided by 1 by 2 raised to n plus 1 whole square. So actually you have multiplied inside by 2. So outside you have to multiply by 4 because there's a square. Yeah. And what is the value of this limit?
It goes to 1, sir.
Yeah. Limit theta tends to 0. Sine theta by theta is 1. This is a well-known identity. So final answer will be 2 by 4. That's wow. Check out the answer carefully.
Sir, can you explain how n tends to infinity will lead 1 by 2 raised to n plus 1 to 0?
How n tends to infinity will lead?
1 by 2 raised to n plus 1 to 0. Like 1 by 2 raised to n plus.
Yeah. So as n become large, and large, 2 raised to n plus 1 will also become large, and large. Do you agree with this?
Yes, sir. Yes, sir.
So it's reciprocal.
Will get
Go.
smaller and
Yeah.
smaller.
Yeah,
Yes,
it
sir.
will get small, and small. So it will approach towards 0.
0. Yes, sir.
Good. Try this problem number 3. So sometimes the sequence may not be defined directly like this, as in the previous 2 examples. It may be given using some kind of expression. The first term is given, then the an plus 1 is in terms of an.
Inductive series, right, sir?
Yeah. A recursive kind of formula. The n plus 1th term is given in the form of previous two terms or maybe previous term, like that. Recursive kind of definition for a sequence. So A1 is 1. So what is A2 by using this? So A2 will be A1 plus A1 square. So 1 plus 1 square. So it is 2. I hope it is okay. What will be A3? A3 again use the same A2 plus A2 square. So what that will be? A2 is 2 plus A2 square. That means 2 square. So that's 6. Yeah. This is how the terms of the sequence goes on. So there are 4 options. A, B, C, D. So one of the option is obviously not correct. What is that option?
Option D.
Option B, sir.
Yeah, option D. Yeah, it's not correct because we can observe the terms of the sequence are increasing kind of thing. 1, 2, 6. And also from the definition, if you observe an plus 1 is nothing but an plus an square. So that's nothing but you can pull out an 1 plus an. So you are multiplying the previous term by some factor, and that multiplying factor is greater than 1. So the value of the term will increases. It will not decrease. Yeah. Am I clear?
Yes, sir.
Yes. Good. So it is increasing kind of sequence. So it will not obviously go to 0. So option D is ruled out. So either I'll have option B, C, or A. So you can also observe limit n tends to infinity of an. Where does the sequence actually goes? It's increasing sequence. We have observed already
Infinity
here.
only.
Yeah. And it's not bounded. So it will go to infinity. So if your sequence will go to infinity, its reciprocal will go to
0.
0. Yeah. So obviously, one of the correct option is B. Any other option? So option C is ruled out.
Sir,
But
A is
there's a
also correct.
It's also right.
Yeah. Good. So this is a kind of question where you have more than one options are correct. So this you can actually solve and see. A4 is also. First option is also correct. Is it visible, the next problem?
Yes, sir.
Yeah. The greatest lower bound of the set. So there is some set is given. And we want to calculate its greatest lower bound. I hope lower bound is fine for all of you. And the greatest lower bound, the definition you all are aware.
Yes, sir. Yes, sir.
Yeah, good.
It will be 2.71.
So first thing I would like to ask here is that if you call xn is equal to this e raised to n plus 2 raised to n whole raised to 1 by n, then is it possible to compute limit of xn? Yeah.
Yes, sir. It will be 1.
It will be 1.
So it will be E1 or 2.71.
Okay, so at least some of you feel that this limit exists, at least. Yeah. Let's say what is the value of the limit soon. So assume limit of xn is L, some L. We do not know what is that L. Someone has already said it is 1. Let's see whether it is correct or. So what does this mean? This means says that limit n tends to infinity of e raised to n plus 2 raised to n whole raised to 1 by n is L. Yeah. So I want to evaluate this left hand side limit. I actually want to calculate value of L. So, but you have n coming at the base and as well as coming at the power. So whenever this kind of expression comes in picture, x to x, if you want to deal with this kind of expression, you need to take log on both sides. So take log on both sides. As being a continuous function, log can travel inside the limit, and you have log of e raised to n plus 2 raised to n whole raised to 1 by n is equal to log L. Yeah, is it okay?
Yes, sir.
Yes, sir. Is property of log that 1 by n will come down, 1 by n into log of e raised to n plus 2 raised to n. That's log L. This implies one n is equal to log L. Now observe the left hand side limit. Now something manageable kind of we end up getting. There is something in the numerator and something in the denominator. Where does the denominator goes?
Infinity.
Both are infinity upon infinity, so I think we can apply L'Hopital rule.
Yes,
L'Hopital
yes, very good. Yeah, yes. We can apply L'Hopital rule. So numerator also goes to infinity and denominator is also goes to infinity. As n become large and large, so we can apply L'Hopital rule. So let's apply. So this limit will be equal to derivative of numerator and derivative of denominator. So derivative of numerator is 1 by e raised to n plus 2 raised to n into e raised to n derivative is e raised to n plus 2 raised to n derivative is 2 raised to n into log 2. Yeah, that's the derivative of numerator.
Yes, sir.
Divided by derivative of denominator is 1. So when we are computing this derivative, the variable of differentiation is n. Variable of differentiation is n. Okay. Now where does this goes? How will you evaluate this? So we end up getting something like this. So again, do you feel it is infinity by infinity kind of thing?
Yes, sir.
So is it tempted to apply L'Hopital rule again?
Yes, sir.
Yeah, but or any other way?
Can we divide?
Yeah,
Both sides by
Divided by
and
e to the power n.
yeah. We divide numerator and denominator by the larger number amongst these two. So whether e is bigger or 2 is bigger, which is bigger?
E is bigger.
Yeah, e is bigger. Very good. So what you will get after this is 1, 2 by e raised to n log 2, 1, 2 by e raised to n. It's equal to log. And then we observe here that this limit is 0 as n tends to infinity because the value of a here is 2 by e
less than 1.
less than 1. So a raised to n goes to 0. Yeah. So what left on the left hand side is L only. And the right, sorry, 1. And on the right hand side, log L. So what is the value of L from here?
0.
E raised to 1.
e to the power 1.
Yeah. Okay, so what we have got? We have got that e raised to n plus 2 raised to n raised to 1 by n. The sequence goes to e. Goes to e. Does our solution ends here?
No, sir.
No.
Yeah. What is the problem? The problem says that you need to find greatest lower bound of the set. So if the sequence goes to E, does that imply E is the lower bound of this set?
Yeah.
Yes, sir.
Okay, so why do you feel it like this? Okay, so
Because, sir, this is an
Sir,
increasing
because
sequence.
it's a monotonic sequence, and monotonic sequence is, if monotonic sequence is bounded, then the upper bound will be the uh, convert, means the limit of the sequence.
okay, so you are using one more property of a sequence, that the sequence is monotonic. Yeah, am I correct? But have
Yeah.
you checked it whether it is monotonic or not? We haven't checked. We have just computed the limit. So you can probably check whether it is monotonic or not. But instead, I prefer this. You compare these two terms. Which one is bigger and which one is smaller?
E raised to n is smaller, sir.
Yeah. Can I say this e raised to n is strictly smaller than this?
Yes,
Or
sir.
all n in n? So you take nth root on both sides. I hope the inequality is preserved when we take the nth root on both sides. Left hand side
Yes,
you'll
sir.
have e, on the right hand side you have xn. Yeah.
Yes, sir.
Yeah. So every term of the sequence is greater than e. That's what we have
Yes,
proved. We
sir.
haven't proved it is monotonic or something like decreasing or something like increasing. Nothing. What we have proved, we have just proved that it is every term of a sequence is greater than e, and its limit is e. So that's why the greatest lower bound is e. So the answer is e. I hope it is okay for all of you.
Yes, sir. Understood.
Yes, sir.
Okay, good. A quick, easy problem. Is it visible? Yeah.
Yes, sir.
Yeah. So can you tell me the correct answer? There are two sequences given. An is equal to 1 plus 1 by n raised to n. I hope this is a very standard sequence, which we know where does it goes as n tends to infinity.
E.
E. Yeah. Very good. It goes to E. And there is one more sequence given. This n into cos of n factorial into pi upon 2 raised to 10. So this sequence is not usual sequence. Let's look at this. What is that? N into cos of n factorial pi upon 2 raised to 10. So there is something like n into cos, this function. What do we know about sine and cos, these two functions?
Sir, they are bounded and option C will be correct.
So
Yeah,
this is bounded
yes.
between -1 to 1.
Yes. So this is a bounded sequence. This is a bounded sequence. Correct. This bounded sequence, but this coefficient n is not bounded. It will go to infinity. Yeah. So Bn is not bounded, but An is convergent. So correct option is C. I hope. First option is
Actually,
not wrong.
Sir,
sir,
First option is wrong. Yes.
please explain this problem, sir.
Yes. The problem says like this: there are two sequences and the four options. They
Okay.
talks about whether an is convergent in some of the option. In some of the option, they says about an is not convergent. And about bn, they are saying only two options, whether it is bounded or unbounded. So we already know that an is convergent. So these two options are ruled out because these two options says an is not convergent. So the left options are A and C. we are trying to observe Bn. What is Bn? N into cos of n factorial pi upon 2 raised to n. So what do we have observed is that this term cos is a trigonometric function and it is bounded. Irrespective of the angle is bounded, but there is a coefficient. There is something in the coefficient. In the coefficient we have n, which goes to infinity. As n tends to infinity, this n will also go to infinity. So this coefficient n will force that Bn is unbounded. Do you agree with this?
Yes, sir. Okay, sir. Sir, why you say 1 plus 1 by n the whole power n is e?
Because it's a standard sequence. It's not e. The an goes to e.
an?
An goes to e. An converges to e. Limit of the sequence is e. That's what I said. Yeah.
Okay, sir.
So an is convergent and Bn is unbounded. Good.
Sir, in the previous question, we can do it in a simpler method as well.
Which can you?
Sir, just previous question.
Yeah.
Sir, if
This one.
yes.
Can you explain what do I mean? What do you mean? Simpler means?
Sir, limit n tends to infinity, that whole will equal to L. Then after taking the log,
yeah,
if we'll do e to the power n, if we'll divide that by the smaller quantity, that is, or the larger quantity, that is e to the power n.
Here itself you mean to say that divide by e to the power n.
Yes, sir.
So how will you get?
Then the inside quantity will become.
This is how you mean, I hope.
Yes, sir.
But how will you go inside the log?
But limit is inside the log.
Yeah, but to bring this 1 by n at the coefficient, to bring this 1 by n down, we have taken log.
Yes, sir.
So after taking log only, this 1 by n is coming down. Yeah, do you agree?
Yes, sir. Yes, sir.
Yeah. So,
okay.
So you need to apply L'Hopital at least once, so that log will go off from the picture, from the left hand side.
Yes, sir.
Yeah. Is it okay? Good.
So, sir, once we interchange log and limit and do some operations based upon logarithm, then we cannot change the sequence, no, sir?
Yeah. Means log is a continuous function, so we are using its property. It can travel inside the limit and so on. So whichever operation you are applying, you need to be mathematically correct.
Got it, sir.
Yeah. Can you try this problem exactly similar to
Hello, sir.
the greatest lower bound of? Yes.
Sir, in the previous question about the Bn sequence, it is asked whether it is bounded or unbounded. But if in the question it is asked
Yes.
whether Bn sequence is divergent or oscillatory or unbounded, then which one will be the most appropriate answer?
Let me listen. Divergent, oscillatory, or
Answer unbounded.
unbounded.
Yes, sir. So which one will be the most
Actually, both these
appropriate?
options are correct. Both are correct, divergent and unbounded. It is certainly not oscillatory. In the sense, when we say something is oscillatory, that means it is fluctuating between only two terms. And here,
Sir,
Uh-huh.
but this sequence oscillate infinitely, na? Minus
Yeah, but
infinity.
it does not oscillate only between two real numbers. It oscillates between infinitely many real means it oscillates in the sense one term is positive, second term is negative, positive, negative, positive. It's like that.
Had the n not be there at the start, then it would have been oscillatory.
Okay, you mean yes, yes. If this n wouldn't be there,
Yeah, then it would have been oscillatory.
yeah. Then also you need to see whether is it oscillating only between two terms or maybe something like that.
Oh, okay.
Because it's n factorial. You need to try computing some terms, and then you need to see whether it is actually oscillating between only two terms or it may not be oscillating.
But sir, by using graph, you can say that now.
Yeah, the cos graph is, I hope it is like this. But n factorial pi by 2 raised to 10, this quantity, this is not equally spaced on x-axis. Say, for example, it is taking this positive value and this negative value for all terms of the sequences, for all terms of this. Then you can say it is oscillatory because it is like here positive, negative, same term, magnitude is same. But if it's something like this real line, first term is here, second term is here, third term is here, fourth term is here, fifth, sixth, or maybe magnitude may not be same. So it is oscillatory in the sense of positive, negative. Positive, negative. So alternating, you can say alternating kind of thing. Oscillatory is a very like typical word if it takes only two values. Say, for example, -1 raised to n. So this is oscillatory sequence because it oscillates between only two terms. -1, 1, -1, 1, -1, 1. Yeah.
Sir, I have a non-technical doubt that are these questions from IIT JAM previous year question, or is it just you have collated to help us understand?
Most of the questions are from previous year JAM question papers.
Okay, okay, sir. Thank you.
Yeah. For example, I think this question is from 2022. No, sorry. 2023.
Oh, okay, sir.
Can you try this? It's not difficult. You call this as limit L, and then obviously we want to bring down this 1 by n. So the usual trick is take log on both sides. So what you will have?
So we'll get 1.
Yeah. 1 plus 1 by 2 raised to n. Take it as L and take log. So you'll have something like this. 1 by n into is equal to log L. Yeah. Now where does this goes? Where does this 1 by n goes as n tends to infinity?
0.
0.
And where does this log of this bracket will goes as n tends to infinity?
Log 1 is equal to
1.
0
Is it
as
one?
well.
Yeah,
No,
yeah.
no, 0,
sir.
0, 0.
Yeah, this also goes to 0 and this bracket also goes to 0. So left hand side is 0. So 0 is equal to log L. So L is e raised to 0. That's 1. Yeah. Is it okay?
Sir,
Yes, sir.
Yes.
here nth root function will be an continuous function. So we can directly take limit inside that bracket.
which
So this
that
question
means you mean to say how can we take limit inside this bracket here?
yes, sir.
We can split the limit over 1 by n and over this log term. That's algebra of limit. Yeah. And then when we take limit inside this log, this will be limit of 1 by n multiplied by limit of log of this bracket.
Yes, sir.
So when we are taking limit inside of this log, that means we are using continuity of logarithm.
Yes, sir.
Yeah, and that is continuous. That is continuous.
So here 1 by n tends to 0 and log function is a bounded function. So in this way we will get 0.
Log function is bounded function? Do you believe log is bounded?
No, sure.
What is the graph of log x?
It goes from minus infinity to infinity.
Minus infinity to infinity?
But sir, it depends on the base E.
Yeah, it goes like this. I hope this is log x. It is defined only on open 0, infinity. Log of negative numbers is not defined, and the graph is like this. Yeah, I hope this graph you must have seen. As you go close and close to 0, log of x will go to minus infinity. And as you go on the plus infinity on positive x-axis, log will go to infinity. So it's not bounded, I hope. It's not bounded. Yeah, is it okay?
Yes, sir.
Sir,
Yes.
sir, do we get the PDF notes after the end of the class?
Do you want this PDF notes? I will supply it to the organizers. Organizers may share with you the notes. Will it be okay?
Yes, thank you, sir.
Yes, sir. Please.
Okay, so I will share the PDF with the organizers once all 4 sessions are over, and then you can go through. Will it be okay then? Yeah.
Okay, sir.
Sir, is there any Telegram group so that we can collect from there?
I'm not sure
Yeah.
exactly how the organizers are sharing the.
Yes,
Yeah.
sir. There is a Telegram group which you are supposed to join. After registration, you might have got the link. So you may join that.
Okay. Okay. Okay.
Okay, ma'am.
So I request all of you, you can try solving past year papers for this topic, sequence and series. One more lecture we will discuss sequences, and the next 2 lectures we will discuss series. Okay.
Okay, sir.
Yes, sir.
Okay. So for today, we will stop here. We'll continue the next session as per the schedule. Will it be okay?
Okay, thank you, sir. Thank you, sir.
Okay.
Thank you,
Thank
sir.
you.
Thank you,
Thank
sir.
you, sir.
Thank you,
Thank
sir.
you all of you for
Thank you,
that.
sir.
Thank you, sir.
Thank you. Yeah.
Sir, option C is correct, I think, for this question.
Option C.
Yes, sir. AN is not convergent, but BN is convergent.
Yeah. Yes. Yes. Rest of the students can try this question.
Thank you, sir.
Yeah. Thank you.
Anybody have any query? Students?
No, ma'am.
Thank you so much, sir, Deepak sir, for today's session. I would also like to thank our one of the resource person, Gaurav Sawant sir, who has been through there with us today.
Thank you, madam.
Sir, one of the query the student have asked that I have a doubt. We say a boundedness of a sequence is like there exists capital M greater than 0 such that mod an less than equal to capital M. But here if we split the mod, we get minus M less than equal to an less than equal to capital M. But there are some sequences where its upper bound is different from lower bound irrespective of its opposite sign. Example, A and B are sequence.
I could read in the chat box, madam. Yeah. I hope the student is still there in the meet. Matthew Aswant, are you there in the meet? Okay, his doubt says that.
I think he is not there in the meet.
Okay.
He's there? Sir, he is there.
Okay, so your doubt says that boundedness of a sequence, that means mod n less than equal to m. So you have minus m, the value of n lies between minus m and m. Then you say a sequence is bounded. At the same time, if I have two different bounds, lower bound is different than upper bound, then I can still have a common bound. I can choose one of the largest number, like 3, then the sequence lies between 2 and 3. It is also lies between minus 3 and 3. It is also lies between minus 3 and 3. So essentially, boundedness is important. It does not matter what is upper bound and what is lower bound. Boundedness plus monotonic implies convergent. I hope it is clear to you.
Yes, sir, understood, sir. He has replied to the chat box. Okay, thank you so much, sir.
Yes, okay.
Thank you. अभी डालते ना the telegram link. Dear participant, the telegram link is there in the chat box. You can join through it. Where is the link? Yes, we have again posted the link of Telegram. You can join through it.
Thank you, ma'am.
Please follow the brochure's schedule for the upcoming classes.
Sorry, ma'am, can you repeat what did you just say now?
Please follow the brochure's schedule for the upcoming classes.
You have shared the brochure in the Telegram group?
Yeah. We will share. Okay. It is not there in the Telegram group, but we will share soon. Okay?
Okay, fine.
Yes, you may leave the group now. This meet.
Okay.
Yes.
Thank you, ma'am.